So this is an introductory video on our inequalities unit, and we have just finished up with our equations where we are solving things that have an equal sign, and our inequalities are going to be using the greater than or less than symbols, and then sometimes they'll also be or equal to with that little line up underneath it. Okay, so the first thing we want to do is just reviewing when we would use these symbols versus when we use an equal. So for example, if you're comparing 4.5 to 8.6, obviously 8.6 is way bigger. They do not equal each other. This side is more. Now when you see 5/6 and 5/6, that's when obviously you'd use an equal sign, that this side equals this side. Now for this third example here, -3 is closer to 0, so it's bigger. For the next to last example, -5.2 is closer to 0 than -6.3, so it's bigger. And for the last one, you might be tempted to either cross multiply and say, okay, so this is a 27 and this is a 32 and so on. Or you might make this a decimal and make this a decimal and say, okay, so this is a 0.375 and this would be the 0.44 repeating. And so what might happen is some of y'all might think that this side's bigger. However, I want to point out that this has a negative, so we don't even got to think about it. Obviously, this positive side is going to be bigger than this negative side. Okay. All right. So for this second question here, when it asks, when do we use these symbols, the greater than or less than signs, when comparing two values? We're comparing up here that this side's bigger than this side. All right. Now, when do we use the equation symbol? When one expression on one side equals another. Here's what I mean by that. We could say that 2 times 3 equals 6. So this was a numerical equation. We could say that if you multiply length times width by height, that would equal the volume, and that would be an example of a variable equation. And we've seen things like x plus 5 equals 13, and that's an algebraic equation. So when one expression equals another expression, that's how you know you've got an equation. And what we're going to be looking at now in this new unit is the greater than or less than symbols. So let's explore some similarities and differences between the two units. So some stuff that you already know would be here in example number 4. We have that the SCA has purchased $25 gift cards as a thank you for the teachers who helped with the dances. So if the SCA spent a total of $275, again, we're given the total, so they spent $275. We have that it equals $275. We also know that it's $25 per gift card. I might use a G here for this, so that if it's $25 per gift card and they spent $275, we can now divide both sides by 25 to get here that one gift card, so that they must have gotten 11 gift cards, all right? So there's one set answer here. We must have had 11 teachers who got gift cards, okay? There's one answer. Now let's take a look at this next scenario and how the problem's a little bit different. So in this scenario, Aurora's family is going on vacation and they have set aside $450 for the hotel room. Now the hotel room costs $75 per night, so that's going to be our coefficient of our variable, and we want to know how many nights can they stay. Now one important thing to consider here, y'all, is that they have set aside $450. Nobody says that they have to spend exactly $450. We just know that the $75 per night has to be less than, or it could be equal to, the $450 that they've set aside. So now when we go on to solve this and divide both sides by the 75, we can see here that they can stay for less than or equal to 6 nights. Now let's pretend that they want to stay for just 4 nights. And y'all, if it's 4 nights and they're paying $75 per night, that's going to cost them $300. And so they would be under budget. So what we're starting to see here with these types of problems is that there's going to be, you might want to write this down, more than one answer. Okay, with inequalities, that's the whole difference here now, is there's going to be more than one answer. That's a big difference here. There's going to be more than one answer. They could stay for 2 nights and only spend $150 and still be under budget. Now, if they stay for 6 nights, if they do stay 6 full nights, that's going to cost them exactly $450, and then they'll be spending all of the money that they spent aside, or that they set aside, but that's okay because it's anything up to 450. They just can't go over 450. So that's why we put the less than or equals to, and we do not need to put exactly 450 because no one says that they are staying exactly 6 nights. We just want to see approximately how many nights they could stay and still be under budget. So here's kind of the main difference between the two scenarios here. This was question 4, where we had that it was $25 per gift card, and they spent $275, and we got here that they purchased 11 gift cards. So there was one finite answer, only one. We have a limited finite answer, and right here, if we were to graph that, we would say, okay, there's the 11 gift cards that they purchased. Now over here, this was the one where we said $75 per night, and it just cannot exceed 450. It has to be under 450. So we got that it'd be less than or equal to the 6 nights. So that means they could stay for 6 nights, or all of these other solutions. And when we're graphing x is less than or equal to 6, this is how it's going to look on the number line. So you might remember from elementary school that if it was just x is less than 6, that's when it would be an open circle, and then you would shade. But because of the or equal to part, we are coloring it in, okay? Now realistically, in red, let's think this through. 6 is the maximum number of nights you could stay, and you could stay all the way through. They might not even go on vacation, so they could stay 0 nights. So now in red, we've shown the realistic solution set on the number line, that it's anywhere between 0 and 6 nights. But in general, I just wanted to review how you'd graph this on the number line if there was no word problem, and that's how it would look. So the big main takeaway here from this is, how many answers are there to an inequality? There is an infinite number of answers. There's more than one. It can be unlimited. So for example, if we're talking about how, if you see x plus 2, so any number in the world, I'm going to add 2 to it, and I just want that to be less than or equal to 10. So as long as my answer that I plug in here is less than or equal to 8, it should work out. So let's try 8. 8 plus 2 is 10. That would work. What if we tried 7? 7 plus 2 is 9, and 9 works. What if we tried 0? 0 is less than 8. So 0 plus 2 is 2, and that's less than 10. So that's what I mean by there is an unlimited number of answers when it comes to an inequality. So you have an infinite number of solutions versus a finite number of solutions with an equation. Now, while we're on this video, I'm going to have you go ahead and flip over to page 2 and just explain how, how page 2 is going to work. So in the boxes, we have a bunch of different potential numbers, and we want to see which ones are going to make these statements true. So for the first one, for example, if you plug in a -1 right here, just ask yourself, what's -1 plus 7? Okay, so this is 6. And now you want to ask yourself, is 6 less than 15? And since it is, we would select this one, okay? So now you're basically just going to take all of these other numbers and just plug them in for x. And if it is a true statement, then you circle it. And if it's not, you wouldn't circle it. Let's take a look for number 4. Just be careful here. For number 4, notice it says select the value that makes this statement true, while for all of the other one, it says to select all possible answers. And that's because you'll notice that for 1, it's an inequality, inequality, inequality. So we're expecting more than one answer. But over here with the equation, only one of these will work. For number 7, I just wanted to point out here for number 7 that you're taking these numbers and you're plugging them in and just divide it by 6. So for example, I'm going to take 60. If I do 60 and divide it by 6, that's 10. And 10 is not less than 9, so we would not select 60, okay? Because 10 is not less than 9. That is not a true statement. All right, so that's what you're doing for this worksheet. Careful with number 9. If you want to just make this 1/2 a 0.5, it'd be very easy to take each of these values and just add 0.5 and see which ones are less than or equal to the 2.5 when you select. And that concludes the video on pages 1 and 2. Thank you.